Okay, this is Kinetics and Equilibrium unit review for the test this week. Collision theory states that a reaction is most likely to occur if reactant particles collide with proper energy, meaning activation energy, and orientation, meaning bond angle. An effective collision reaction occurs. Particles are lined up, you have the right amount of energy, and a new product forms. An ineffective collision, the reaction does not occur, regardless whether the right amount of energy is present or not. Which event must always occur for a chemical reaction to take place? Hopefully you said choice 3, effective collisions. As we go through this, for each question, just pause me until you can read your choices and make your own answer, and then continue to check your answer. The rate of a chemical reaction depends on several factors: temperature, concentration, nature of the reactant, surface area, the presence of a catalyst, and pressure if there's a gas. We discussed each of these in length in the unit. We'll review them now. An increase in temperature will produce a faster rate. There's more kinetic energy, therefore the molecules move faster, and they collide more often and with more energy. An increased concentration is also a faster rate. You have more solute particles per unit volume, which means that there's more particles to collide with. An increased surface area, meaning smaller particles, will also produce a faster rate, as there are more sites for collisions to occur. I give you the example of granular sugar versus a sugar cube. Granular sugar dissolves much faster in hot tea than a sugar cube because it has an increased surface area and more sites for collisions to occur. The nature of the reactants: an ionic compound versus a covalent compound. Ionic compounds react much faster because there are fewer bonds which require less energy, as opposed to a covalent compound that has multiple bonds and requires more energy. Solids react more slowly and gases react more quickly because gases have more entropy or randomness and are spread out further. Ionic solutions react more quickly than ionic solids because in ionic solution, example NaCl, the bonds are already broken. And you have Na ions and Cl ions. Some chemical and physical changes can reach equilibrium. We have 3 types of equilibrium: phase equilibrium, solution equilibrium, and chemical equilibrium. We reviewed phase and solution equilibrium, and as you know, much of this unit focuses on chemical equilibrium. In phase equilibrium, we're talking about an equilibrium between phase changes, a solid to a liquid at its melting point, or a liquid to a solid at its freezing point, or between a gas and a liquid, or a liquid and a gas. Solution equilibrium occurs when the solution is saturated and the dissolving rate equals the recrystallization rate. Lastly, chemical equilibrium. Reversible chemical reactions can reach equilibrium. What type of change, if any, can reach equilibrium? Hopefully you said both chemical and physical. At equilibrium, the rate of the forward reaction equals the rate of the reverse reaction. That is the only thing that is equal at equilibrium, is the rate. The measurable quantities of the reactants and products remain constant at equilibrium. We read the double arrow is in equilibrium with. So a double arrow means that the products are in equilibrium with the reactants. We can also use an equal sign, and other forms of double arrows may look as such. At equilibrium, the concentrations do not change. In the reaction below, hydrogen and nitrogen are changing into ammonia gas as fast as ammonia gas is breaking down and turning back into hydrogen and nitrogen gas. The amounts of each, meaning their concentrations, are not necessarily equal. Only the rates of a reaction are equal. At equilibrium, the concentrations do not change. Given this example of a reaction at equilibrium at STP, What statement correctly describes the system? Hopefully you said that the forward and the reverse reaction rates are equal. Choice 1. Which statement correctly describes a chemical reaction at equilibrium? Well, we know the rates are equal and the concentrations of the products and reactants are constant. Choice 2. The equation for the saturated solution equilibrium of potassium nitrate, KNO3, is shown below. You have a solid, it's an endothermic reaction, and it produces K plus aqueous and NO3 minus aqueous. What do we know about the dissolving of KNO3 with the rate of recrystallization of KNO3 for a saturated solution? Well, we're at equilibrium and it's saturated. So we know that in solution equilibrium, a saturated solution is when the dissolving rate equals the recrystallization rate. Le Chatelier's principle can be used to predict the effect of stress, meaning a change in pressure, volume, concentration, and temperature on a system at equilibrium. When you add something, the reaction tries to use it up. When you remove something, the reaction tries to replace it. Changes in pressure only affect gases. Changes in temperature have a greater effect on the endothermic side. And remember, a catalyst does not cause a shift in equilibrium. It only changes the reaction pathway by lowering the activation energy. This is another way to look at equilibrium, using a seesaw model. I like saying if something increases, or the balloon model, if you squeeze a balloon, then the air travels to the other side. If you let your hand off a balloon, then the air comes back. This is just another way of learning equilibrium. It's like a seesaw. If you have the reactants on the left side of the seesaw and the products on the right. Pressure can start on the side with more moles of gas, and temperature can also be a reactant or a product depending on the type of reaction it is. So, we use square brackets to indicate concentration. So if I have H2 in brackets, it's red, the concentration of H2. If I increase anything on one side, that side goes down and the other side goes up. So in this example here, if we increase H2 on the seesaw, that side goes down. Because increasing H2 is kind of like putting a rock on that side of the seesaw. You're adding more. So if you add more, then the other side goes up. If I remove something from one side, the other things on that side go up and the other side goes down. In this example, if I decrease the pressure of H2, it's like taking a rock off the seesaw, which makes that side lighter, so that side goes up in the air, and the other side goes down. You have to decide which method is easier for you to understand. The balloon method, this method, or just simply knowing that when you increase something, the shift is away from that side, and if you decrease something, the shift is toward that side. So, as I was just saying, add to the right, shift to the left. Add to the left, shift to the right. Remove from the right, shift to the right. Remove from the left, shift to the left. So using our example of the formation of ammonia, what will cause this reaction to shift to the right? Well, I can increase H2, it'll shift right. I can increase the concentration of N2, it'll shift right. I can decrease the concentration of NH3 because when we decrease it goes toward the shift. Same with temperature. I can decrease the temperature and it will go to the right. And if I increase the pressure, remember it shifts to the side with the least number of moles. 3H2 plus 1N2 is 4 moles on the left versus 2 on the right, so an increase in pressure will indeed shift the reaction to the right. If I wanted to cause a shift to the left, I could decrease the concentration of either H2 and N2, and it would go toward the decrease. I could increase the concentration of NH3, and it will go left to use it up. I can increase the temperature, it will shift left. And when I decrease the pressure, it shifts to the side with the most number of moles, which would be, again, to the left. Given the equilibrium reaction in a closed system, what will result of an increase in temperature? Notice temperature is on the left, so if I increase it, it will shift to the right, it will drive the forward reaction, and HI will increase. Choice 3. Given this system at equilibrium, what will be the result of an increase in temperature? Temperature is on the left, it's endothermic, so if I increase temperature, it's going to shift right, favoring the forward reaction, which means that NO2 will increase. Choice 4. Energy released or absorbed by a chemical reaction can be represented by a potential energy diagram. Remember, from the x-axis to the reactant line is the potential energy of the products. From the x-axis to the product line is the potential energy of the products. The difference between the potential energy of the products and the potential energy of the reactants is delta H, our heat of reaction. From the x-axis all the way to the top of the hill would be our potential energy of the activated complex, and the activation energy goes from the reactant line to the top of the activated complex. Evidenced here is the forward activation energy. The reverse activation energy would go from the product line to the top of the activated complex. Energy released or absorbed during a chemical reaction is called the heat of reaction, and it's equal to the difference between the potential energy of the products and the potential energy of reactants. P minus R. Let's compare the two diagrams. In an exothermic reaction, our curve is downhill. Potential energy is decreasing because it's releasing energy, and our products are lower than our reactants, which means that our delta H will be negative, and energy appears on the right side when it's in an equation. In an endothermic reaction, our potential energy is increasing, meaning it's absorbing energy, which is evidenced by the products being higher than the reactants, resulting in a positive delta H, and energy is on the left side when written in an equation. According to Table I, which potential energy diagram represents the reaction that forms H2O liquid from its elements? Not the gas, but the liquid. Notice that there's a negative delta H. The reaction is exothermic, which is choice 1. Which statement correctly describes an endothermic chemical reaction? Well, in an endothermic reaction, we know that we're going uphill. Potential energy is increasing. Therefore, products must be higher than the reactants, and delta H would be positive. So choice 2. Activation energy is the energy needed to get a reaction started to reach the activated complex. The potential energy diagram below represents a reaction. Which arrow represents the activation energy of the forward reaction? Hopefully you chose choice B. Enthalpy, or energy, is the heat of reaction, or the change in energy. This value has the same magnitude in the forward and the reverse reaction. Only the sign changes. It's measured in kilojoules. When delta H is positive, it means that the reaction is endothermic and energy is being absorbed. When delta H is negative, it means that the reaction is exothermic and energy is being released. The larger the value delta H, the more energy absorbed or released. Remember, Table I gives us delta H for many reactions. And this is what it looks like. Given the reaction, methane and oxygen produce carbon dioxide and water. What is the overall result when methane burns according to this reaction? Well, you can look it up in Table I, but you should also recognize this as a combustion reaction, when a compound combines with oxygen to produce carbon dioxide and water. And you know that combustion reactions are very exothermic. Therefore, energy is released, and delta H would be negative. But you should also double check in Table I and see the negative delta H value. According to Table I, which one of these salts releases energy as it dissolves? So this is another way of asking which one has a negative delta H, and that would be LiBr. Given the reaction, what is the approximate delta H for the formation of 1 mole of water? We had this as a do now question earlier in this unit. Notice that our reaction gives us 571.6 kilojoules for the formation of 2 moles of water. So the first thing that I want to do is cut this value in half because I'm only asking about 1 mole of water. So that narrows my choice of answers to choice 1 or choice 2. I also need to notice that the energy values on the right side of the equation, which would be indicative of exothermic and therefore a negative delta H, which would be choice 1. A catalyst provides an alternate reaction pathway which has a lower activation energy than an uncatalyzed reaction. Therefore, it takes less time for the reactants to change into products. Adding a catalyst affects the amount of energy, so the activation energy, and it also affects the potential energy of the activated complex. According to Table I, we already did this question, which salt releases energy as it dissolves? It's a repeat. Given the reaction A plus B yields C, does the diagram illustrate an exo or endothermic reaction, and state one reason in terms of energy to support your answer? Well, we're going uphill, so it's endothermic, and our potential energy of our products are higher than the potential energy of our reactants. Or energy is being absorbed, or potential energy is increasing. If we were to add a catalyst to the diagram, it would look something like this. A catalyst speeds up both the forward and reverse reactions equally. Using a catalyst will not affect the equilibrium. A catalyst is added to a system at equilibrium. If the temperature remains constant, the activation energy of the forward reaction will decrease because a catalyst does affect activation energy. Given the reaction at equilibrium, state the effect on the number of moles of nitrogen gas if the temperature of the system increases. Well, notice that the temperature is on the right side of the equation, therefore, an increase in energy will cause the reaction to shift to the left. If it's shifting to the left, it's driving the reverse reaction, which means that there's an increase in N2. State the effect on the number of moles of H2 if pressure increases. Well, when I increase pressure, it's going to shift to the side with the least number of moles. So notice here we have 3 plus 1, which equals 4 moles of gas on the left versus 2 moles on the right. So it shifts to the side with the least number of moles. So the shift is going to be to the right. And if we're shifting right, the effect that that will have on H2 is H2 will decrease. State the effect on the number of moles of NH3 if a catalyst is introduced. Remember, a catalyst only affects the activation energy. It does not affect the concentration of the products or the reactants. Therefore, it has no effect, and the moles would remain the same. Entropy is a measure of randomness or disorder. A system with greater disorder has greater entropy. Solids are very ordered. They have low entropy, as gases are very random and have high entropy. Entropy increases when a phase change makes it more disorganized. For example, going from a solid to a liquid or from a solid to a gas. Entropy is increasing. Or more moles of gas are produced. Entropy also increases when something dissociates. So if you have NaCl solid dissolve into Na plus and Cl minus, then the bonds are already broken and it's easier for a reaction to occur. Which process is accompanied by a decrease in entropy? So decrease in entropy means that I'm becoming more ordered. Well, 1, 3, and 4 are becoming less ordered. Boiling of water is liquid to gas, subliming of iodine is solid to gas, and melting of ice is solid to liquid. The only one that has a decrease is choice 2. We're going from gas to liquid. Which sample has the lowest entropy? Don't get caught looking at the substance, you're only looking for the state of matter. Solids have the lowest entropy. As carbon dioxide sublimes, its entropy increases. You have to know that sublimation is a phase change from a solid directly into a gas. Systems in nature tend to undergo changes toward lower energy, or enthalpy, and higher entropy. A reaction which is exothermic and increases entropy will always occur spontaneously. A reaction that is endothermic and decreases entropy will never occur spontaneously. Reactions that depend on temperature. That means when entropy and enthalpy don't agree. If a reaction is exothermic and decreases entropy, or when something is endothermic and increases entropy. Changing phase depends on temperature, because entropy and enthalpy can't agree if the reaction should proceed or not.